So I think everyone who wanted to join us has already done it. Thanks again for joining us today. Allow me to introduce myself. My name is Lianella. I'm Key Account Manager at Tech Internals Community. And today we will have this super cozy, nice meetup from Nick. But before we start, I would like to say a couple of words about our company for you to understand what we do. So let me very quickly share my screen. Can you see my screen now? Nick, is it seen? Yes, great,
Yes,
great.
yes, we can see the screen.
Tech Internals community provides Tech Internals conferences. These conferences are specifically for the developers of high performance and complex systems at scale. We already have quite an experience when it comes to organizing events. We have already organized over 100 of them, and we decided that we need to bring this product to Europe. That's why we provided conferences in Serbia in 2023, in Cyprus in 2024, and the next location of ours is Berlin in May. So in here, you can see the key topics of Tech Internals conferences. We still accept some topics for the next conference we will have in Berlin, but please hurry up because the program almost completed. And this is our program committee. Nick is also part of our program committee. So basically these amazing people, they help us to prepare the program of the conference, and they choose the best topics, the best talks on the competitive basis. And in here, you can see some top talks from our previous conferences, including Amazon Web Services, Mira, Dropbox, Cloudflare, Uber, Percona, and others. For the next conference, we already have some talks accepted from such companies as Red Hat, Netflix, so quite huge names. And that's why we attract mostly senior audience. So our conference is attended by senior plus specialists. So this is all I wanted to share. At the end, we'll have Q&A session, so I would be really glad to answer some more questions if you have some. But then I would like to pass it to Nick, please.
Sounds good. So let me share my screen, and we will go through a number of very interesting things. So today, I'm gonna focus on programmability of NGINX. And why am I the person talking about this? My name is Nick Shadrin. I'm an architect at NGINX, and I've been with NGINX for more than 10 years now. All right. When we are talking about programmable configurations, there is a lot of different aspects we will go through. So one second. Okay, so we will have to divide this conversation in three different areas. So first of all, we will talk about the logical stack of the software, the different areas where programmable part of the configuration can apply. We will talk a little bit, or rather in huge detail, about different languages and solutions that are available to make NGINX web server configuration programmable. And also we will talk about the interfaces through which people can apply the different scripts, programs, pieces of code, and configuration requests to the systems. First, we will need to dive a little bit deeper inside of NGINX web server configuration. And yes, I know I'm just diving straight into that without a lot of introductions or a lot of high-level information. But the reason for that is I have about 88 slides in this presentation, and it will be quite hard to fit everything in this 1 hour that we have. So pardon me for going a little bit faster, but we will have to go this way. So we will focus on three specific products within the NGINX product portfolio. NGINX and NGINX Plus, they share the same core. So everything that I will be talking about, it applies to either of those, NGINX being fully free open source solution available for everybody, and the NGINX Plus being the commercial version of that. But the commercial bells and whistles, they are not different in the sense of programmability or scripting of the configuration. And we will talk a little bit about NGINX unit, the application server that can be placed behind NGINX, so with the variety of different types of backend code. All right. So first, before going further into the different types of scripting and configuration types, we will take a quick look at NGINX architecture. So we see that NGINX being an asynchronous server, it has a couple of unique features. There is the master process that deals with configuration loading, with instantiating of the workers and a number of other management features. There are usually several or several dozen, some low number of worker processes through which the traffic goes, and those worker processes are the ones that are literally processing traffic from the users. Inside of each of those processes, there is a modular structure. And everything in NGINX is designed as its own different module that is written in C. And frankly speaking, this is quite a complicated code. So when I'm saying that everything in NGINX is modular, yes, I mean everything. Like literally, HTTP itself is a module for NGINX. Why is that important? Every module, every basically piece of code that you're writing for NGINX can be bound, can be compiled with the two different methods. One is you are compiling the NGINX module straight inside of the binary, and this is what you can see in NGINX-v. When you're running this command, it shows what was compiled in, and this is what you see there with the -- with. Those modules are straight inside of that NGINX binary. Separately, you can compile modules outside of separately from that. You can take the modules from a different path, which is outside of the normal provided source code. For example, in this example, this person who was taking this, who was compiling this NGINX, took a very different module from somewhere from third party and compiled that inside of that binary. Similarly to that, you can also compile the module outside of the binary and include that dynamically through the configuration. So why is that important? Where that applies? So the other part of NGINX, the main core of NGINX is an event loop, and HTTP traffic for NGINX, HTTP module defines a number of different phases in which the traffic is being processed. So when we're talking about traffic going through the various basically pieces of code inside of NGINX modules, each one of those modules, it attaches itself to different phases of traffic processing. So when we're talking about making configuration more dynamic, we need to know where that applies, where in the processing chain do you want the modification of traffic or different actions on the traffic. So this little introduction, it will be important when we will be looking into scriptable configuration, because you will see the phases of traffic processing in a lot of different places further. All right, next, let's talk about a few different languages that are used inside of NGINX. So the first one is C language, and this is what is done, what is used for writing NGINX itself and writing your own modules or the core modules for NGINX, or to modify the source code itself. Next, kind of a language, it's the format of the configuration. So configuration nginx.conf is designed in a language that has light resemblance with C. It has its own quirks. It has its own kind of format. You can treat it as its own language to some degree. Next is JavaScript, and JavaScript or NJS is the implementation of JavaScript machine inside of NGINX configuration. Those script files can be included with nginx.conf, and different functions, different modules can be created there. Next, Lua. And Lua language, it's a third-party implementation by OpenResty, where the blocks of Lua code can be included either directly or outside of nginx.conf files. And depending on what modules, what kind of nginx build you're using, you can use a lot of different Lua features in it. And in addition to that, there is an older implementation of nginx scripting, which is Perl. And you can reference some Perl functions and Perl modules inside of nginx. And we will not be touching a lot on Perl, and one of the reasons there is that Perl implementation in nginx, it's not just outdated in terms of time, it has a few shortcomings there. It is not as dynamic and as asynchronous as the other implementations of the scripts. All right. So next part of that, let's kind of divide our approach to programmable configuration into the different methods. We will talk as an example as what is that basis of nginx configuration. Then we will talk as the first level of programmable configuration, what can be the advanced nginx config with the regular expression, some if conditions, some other variables, and some other parts there. Next, probably the larger part of the presentation will look into the light scripting, which is basically NJS and Lua. Further, we'll spend a lot, a little bit of time if we have into WebAssembly as the heavy scripting approach into nginx. To some degree, we will also touch the backend or external applications on how the different scripts can be applied on the different level behind nginx. Native modules are not in the scope of this presentation. It is a little bit more complicated to go deeper into the C language to build that. Although if you like to do if you like to modify nginx source code, please go ahead. All right, so first, basic nginx config. This looks pretty simple. We're looking at a clear structure where not that much of programmable features of scripting can be applied. However, when we're looking at a bit of a longer nginx configuration, you can see that some of the conditions are inherently designed into the structure of the config. So for example, here we have two different host names, and we are looking into two different ways of traffic processing depending on the host name. Some might think that you might need to build a script to figure out which host name is what and how to route traffic depending on that host name. But some of those features, they are built into the config, and this is if this is what you need without further changes, just use the plain nginx config and that's it. When we are looking at some more functionality and some more features, you can use features of if conditions in some specific places. Please read the articles on how to use the if directive. It is very important that this is not the preprocessor of the configuration, but rather a very specialty directive. There are other ways of doing advanced nginx configuration, primarily with regular expressions. Those features and those configurations can grow pretty extensive, and they can be quite hard to read. Sometimes it is easier to design those configurations into the various files and move the logic outside of the main configuration file. Many people tend to do that and place specific host-based configurations further into separate files. That helps in configuration management, but it doesn't change the actual complexity of the resulting configuration structure. Another part there is the relationship between two nginx modules, two of the high-level modules, namely the HTTP module that processes HTTPS traffic, and the stream module that can do TCP, UDP traffic without regard to that being HTTP or database or basically anything else. So that module is called stream. You can see a quick example there. All right, so let's go deeper into the different scripts inside of the NGINX configs. First, we will look at Lua. And Lua is a set of modules and a different build of engine. There is a different build of NGINX named OpenResty, and that is created by a third party, not by F5. And it is a pretty widely used example of how the programmable configuration can be done. Lua modules, it is a set of different modules for NGINX. Also, in addition to this, to the Lua modules for NGINX, it has a number of other parts. So when you're looking at Lua-based configuration and Lua scripting, you might very easily be looking at OpenResty as the whole build. That ecosystem includes a number of different NGINX modules, and I'll take a quick look at the very minimal configuration right here. So here we see that in one of the NGINX locations, we're looking at the directive called content by Lua block, and straight inside of that block, we're just placing the Lua code. And it has that special object, which is called NGINX, and you can just basically do whatever you want with that. What other directives can be used there? There is a number of directives available for what you can use inside of the NGINX config. I want to kind of focus on a few of those. And when you look into the subset of directives, which says the Lua block, which basically include the Lua code straight up inside of the NGINX config, you will see those words: content, rewrite, access, header, body filter, and log. And now you will see that when we were looking at the phases of traffic processing, this is basically those phases. So you can use Lua code in the various phases of processing, and this is basically just binding of that Lua code into the different parts of traffic processing inside NGINX. So, for example, when it says log by Lua, it doesn't mean that you have to log or write logs specifically by that directive. No, not really. This is just binding in that phase. You can do all kinds of other things there. Same applies to rewrite or access. This doesn't mean that you need to do the access features or rewriting features. You can do whatever you want, but you need to be mindful at what time this code will be executed. There is another example here, which is the JWT authentication example that is done in Lua. Right here, it's well, this is, I would say, more complicated. We will not go deeper into the details of this functionality. This is basically the illustration that more Lua code and more complicated examples can be used. Okay, so should we use it? There is a thing about Lua code and OpenResty. It is very much possible to build a Lua script that will make NGINX unstable. And the binding of Lua inside of NGINX structures is not necessarily done in a very stable way. So another part there, it's an interoperability within its own set of modules. You might be using a number of different OpenResty features, Lua modules, and you might start combining those, and that might also affect the stability of NGINX underneath. Lua is not very much known in the community. Of course, there are lots of people who know the language, but compared to JavaScript and some other more popular languages, this is more niche kind of development. So should you use it? I would say the main idea is test it really well. Lua has a Lua ecosystem for NGINX has a huge number of examples. There are API gateways, there are authentication modules, there are lots of examples coming straight from OpenResty. It is seriously a very very widely used community and very widely used set of modules. But please test it really well. If you are going that direction, and if especially if you're not an expert in Lua, but you just took some code from somewhere and start combining it with some other pieces of code inside of the configuration, test a lot. All right, let's go further into NGINX JavaScript. So at NGINX, we developed a set of JavaScript modules. And why did we do that? With Lua, there is a different philosophy and different ways of how it integrates into NGINX. And we decided to create our own scripting implementation with the more popular language. We did that experiment in some conferences, asking for a show of hands if somebody wrote a line of code on Lua, and some hands were shown up. But when we asked if you wrote a line of code in JavaScript, pretty much everybody had some experience with JavaScript in their life. So it is popular, it is well known, it lays out better with NGINX, and it is more active in how the language is developed. In addition to that, this is laying out better into NGINX itself. So what we did there, we built our own interpreter. So NGINX interpreter at the time, the available interpreters at the time for V8 or SpiderMonkey, they were not very effective in for the NGINX use case. They were designed for longer running applications, and inside of a traffic processor, inside of the load balancer, you need the different features from the scripting language. You need very quick start, and basically a very quick execution of a small amount of code. And then that VM or that code, it's usually not needed anymore, so it can be destroyed. So what we focused on was a quick start of that JavaScript machine, and we didn't need to take care about garbage collection or other long-running features of the application. It was just easily, it is just easily destroyed after execution. This own interpreter, it has some limitations because we were building it from scratch and for NGINX. So one of the things you should be looking at NJS as basically its own language that is based on JavaScript. It is and another item there, when you're looking at pieces of JavaScript inside of NGINX configuration, don't think of that as a full application server. Use that sparingly for some request level, for some request level quick changes or quick decisions based on that request. If you want to run complicated logic or something really long, you can use that as an application server, and that usually applies to the layers of infrastructure behind NGINX, not on NGINX itself. For our own NJS implementation, this is what we did to make it faster for start and faster for this use case. This is there is no JIT there. It is not it is cloned on every request, and as I said before, there is no garbage collection there. So the main optimizations there, we were designing it for the quicker start and no worrying about running it for longer periods of time. Here's an example on how to use basically a hello world example for NJS. You can include the HTTP.js module which can be compiled, which can be delivered as a separate package for NGINX. It can be compiled when you are downloading NGS from the website and compiling it for your own NGINX. Usually, it is placed outside of NGINX binary, so the module for NGS is dynamically loaded in the configuration. You have to define, you have to create the file with your JavaScript, and that's a separate file, not inside of NGINX configuration. And then you can reference the functions from that file straight inside of your NGINX config. This is a slide from one of the older conferences. This is from one of our friends at Quantil, and he's saying that this is that NGS is an alternative for C modules, and sometimes you can use it instead of those C modules, but use it as a standalone language. This is one of his examples where he is making changes to some header values, and in this example is pretty much very simple. So we're using the this script here, pretty simple. And another interesting example there, which is something that you would need to test really well. It's the extension, it's the usage of JavaScript functions and calling those from the directive definition or from the C code. So here it is defined, here the function if status 200 is defined. It's defined in as a JavaScript function. However, the call of the function is done here from basically from the C code. And we see that we're doing the HTTP JS call to some JavaScript function and recompilation of NGINX is required to have features like that available. So here you see that this if status 200, that kind of parameter, this is not a default parameter of the directive. It was compiled in the C code, but the function itself was not defined in the C code. The function itself was done in JavaScript. Features like that, they require extensive testing. It is very easy to break something or to reduce stability of the software if you're going that direction. When we're looking at the directives available from the JavaScript implementation from NGS, you can see right here, there will be a few very important ones that you might be using. There is the body filter. There is probably content would be very useful. And the JS set as well. This is the one that is defining the variables. All right. Next, inside of NGS, there is a number of different objects that are special objects available from that JavaScript implementation. You can take some properties of the request, some headers, response values, and so on, and also the very special object called NGINX. There is a number of built-in features that you can see and know from normal JavaScript. However, we want to focus on a couple of those. There is the HTTP request functionality, which has a number of methods available. You can see a lot of that and the full description of that in the documentation. I don't want to read the documentation on that during this presentation. The interesting feature there is sub request. So you can actually call other web servers or other locations in NGINX from the same JavaScript code. Further, there is a recent development, the fetch method. This is also available there, and a number of different properties of NGINX they're also available through .NGS. I want to show an example here for the NGINX S3 gateway. And this is an example of a full NGS module that was designed and built in JavaScript. And this is basically the S3 proxy. It is available on NGINX GitHub. It's fully open source, free to use, or free to use as an example for your own code. Okay. The other example there could be seen in another implementation of the S3 proxy. There is this is a different implementation which is built by the members of the community. All right, that's the other example here as well. Okay, so another part of NGS that is available for you is the stream implementation. And as I mentioned before, stream is a module for NGINX that can deal with any kind of traffic, being TCP or UDP or TCP or UDP of any kind, as database, IoT traffic, messaging bus, whatever that can be. And and for that, there is a bit of a different approach in JavaScript. You can still call JavaScript functions for a stream session as well, and you will be able to do some functionality there on that traffic. But I would warn against going too deep into modifying of stream traffic because it might affect performance of the server, or maybe it can be harder to manage or harder to update that kind of traffic. Maybe it makes more sense to take that outside of NGINX and bring it into the application. But it's basically for you to decide for your special use case. Here's an example where we're looking at okay, so for this one, we're looking at different at a part of traffic, and we're searching for. I actually forgot what we were doing here. Yes, I can see we have the feature of looking into some IP addresses and probably looking at a header of some sort inside of straight stream of traffic. All right. This is an example from one of our speakers at Tech Internal set of conferences. Vasily mentioned that with NGS, you're not getting some middle of the night phone calls. Maybe he's getting less of those phone calls. All right, let's go a little bit further deep into the scripting configuration. And this is the fairly new example, which is the WebAssembly. WebAssembly is a promising new technology which lays out well for the traffic processors of different kind. It is a well-defined interface, and it has a very good ability of building small footprint, very high-speed applications with a good level of security and isolation for those small applications. For WebAssembly, we should not look at WebAssembly for NGINX as or for any other proxy for the same reason as a full application language or a full application of a larger scale. It is also the set of scripts and the set of small. It is designed better as a set of smaller applications. There are several community examples there for various traffic processors. For Envoy, there is the specification called Proxy WASM, which is lays out very well into Envoy's internals. And for traffic proxy, there is the HTTP WASM, which is also laying out well for their own software. Well, when we're talking about that implementation of WebAssembly, there is also the WebAssembly system interface WASI, and this is something that is showing promise for our use cases for NGINX. The WASI HTTP proxy is the type of implementation that we will be using for NGINX. However, for now, this kind of functionality of WebAssembly, it's some parts of that they are in preview modes, and some of them are in development, and some of them were just released by some third parties. There is another example of WebAssembly that was just released a few days ago by NG software, where they did their own implementation of WebAssembly, and so far we don't have an opinion on that. It's been literally a few days since it was released. So for WebAssembly, this system is showing a lot of promise, and we will be looking into WASI HTTP proxy as the main method of WebAssembly implementation for NGINX. Okay. So there is not that much about WebAssembly that I'm talking about. This is still early in the technology. We should be looking into that topic further during the year, maybe closer to the Berlin conference, maybe further into 2025. Okay, so now let's look into the interfaces of how the configuration request or scripting request can be applied or can be requested to be applied to NGINX. Inside of NGINX toolchain, there are several areas of making config requests or configure load requests. First of that, this is a signal, and this we're talking about the standard Unix signals, where you can send basically SIG-hub to the NGINX PID, and it initiates the reload. In many cases, when you are changing scripts or changing configuration files for NGINX, you need to instantiate a reload process. So proper understanding of how reload works can be very helpful and very crucial for the production system. You cannot be blindly reloading NGINX every second. That might have some serious performance troubles. You need to be mindful about how you are reloading if you are looking into stream traffic where long-lived connections are persisting with that NGINX as well. So looking into a reloading infrastructure of how you are restarting and reloading NGINX is very important when you are changing scripts more frequently. Next is files. Okay, so what am I talking about here? Well, not every aspect of NGINX, but most aspects of NGINX are managed by managing files. The configuration files, scripts, certificates, and some persistent storages, they are all basically files in a file system. So a good infrastructure that is managing the configuration well, it needs to be managing files correctly. It needs to have the proper versioning, proper way of rolling back those configuration, checking consistency, checking the security, those files, safety of file transfer between the different machines, containers, and so on. It needs to be storing them correctly, maybe not deleting them when it's not needed, maybe deleting them correctly when it's required. So looking at the file management is very important when you want to have a good and stable configuration of NGINX. And when we're talking about those files, now when you will be implementing more JavaScripts, maybe Lua script files, maybe other kind of scripting files, or more complicated config, you might be looking into those files as the same application code system that you're using for your backend. So the backend app code, basically the same idea of file management as you would be using for NGINX. So maybe including NGINX into your code repository, NGINX configs, not the binaries. maybe including NGINX configs, NGINX scripts of various kind, closer to where you are treating your backend application can be beneficial. You might be using the same development structure and the same organizational structure for managing your NGINX files. So don't necessarily treat NGINX as a box outside of your code that is managed by a different team, but rather bring it closer to the application in the organizational ways of how you're managing those files. And another part there, which has some application for NGINX Plus, it's some APIs where some of scriptability or scriptability outside of NGINX for its management, this is where the API can be used, and that's a different functionality. We're not touching that one much in this presentation. Okay, so how much time do I have? There is just probably a few minutes left, but there is enough time to cover a few bits about the backend application. NGINX has a different piece of software called NGINX Unit, and this is a type of application server that is designed to run the backend applications directly. So you can run the standard applications written in PHP, Python, Go, and the whole list of other languages. And you can use their own interpreters, their own ways of running that application, and the NGINX Unit will be the system that is managing that application. So that would be the application server. Unit, in this sense, will be replacing maybe your UWSGI server or something similar to that. It can perform the isolation, and it also provides the API access to the config. A good example is here where we have, this is the example of a unit configuration where your backend applications are defined in that unit API. And you can see that there is a consistent way of defining the application regardless of how or which language it is written on. So when I was talking about having the different approach for JavaScript and Lua done for request level, quick changes, quick actions on traffic or on requests, the backend application is a different story. The backend application can be running longer, and that can be an off-the-shelf, let's say a WordPress application or something you can find in Python or Ruby or whatever other things you might have. That can be basically your main kind of application. Another thing that Unit provides is the different way of routing across those applications. So you can do some of the logic or some of the scriptability straight inside of Unit APIs, and you can define the matching rules and matching routes that can send traffic to the different applications behind Unit. So when we're talking about when to use NGINX with NJS or when to use Unit, there is a different distinction there. And the main ones, it comes here from the optimization for smaller requests or a large number of smaller requests, and Unit as the optimization for off-the-shelf standard applications, standard code that is running for a longer periods of time. For NGINX, there is a more limited type of scripting languages available. You should not be treating JavaScript with NGINX as the plain standard JavaScript. This is a limited special use case. However, for Unit, you can use Node.js in its normal form, the way you would want to use it differently. So we're talking about the traffic manager features versus application server features. Okay, what if we put NJS, the JavaScript, inside Unit? Does it make sense, since that's such an interesting system? Yes. In some use cases and some specialty features, you could be using the JavaScript, basically one-liners or small pieces of code straight inside of Unit API. And here you are looking at an example of a unit API where we're looking at the route, but to define, to make the decision on the route, we're looking at some functionality, that is defined in a form of NGS. This is another example of a limited use case where if you need a quick solution for special kind of routing or special routing on different conditions that are not immediately available in Unit API, you can use it. You can use the NGS inside of that for some quick and small changes. But once again, the same idea applies. This is not a larger application or large JavaScript. Treat that as a more programmable configuration, more changes to the configuration that you might need to do for only some of the cases. This is a little bit of a longer example here. I wouldn't go much longer than what you're seeing on the screen for JavaScript inside of the unit config. All right. There is another example of scripting in Unit or other WASM applications in it. WASM can be treated as a type of an application in Unit, maybe for some of the longer or more computationally extensive tasks. We will not go further into the details there. I'll just refer you to the Unit documentation if you want to run WebAssembly inside of Unit today. There is already available interfaces for that. You can do it. You can do it now. Okay. So what we looked at today, we looked at the basics of NGINX config, some parts of advanced configuration, and then we talked in the longer detail about the JavaScript and Lua ways of running configuration more dynamically. We did not look much inside of WebAssembly. However, we mentioned that. And we definitely did not go deeper into the C code of NGINX. That is a special level of a rabbit hole that we cannot go in a presentation like this. The backend applications are also another way of looking at programmability of configuration. However, my main output from this presentation would be when you're looking at some piece of logic or some piece of code for your configuration or for your business task, find the correct level in the configuration stack or in the tool chain where that code actually applies. Sometimes it makes sense to run it closer to the user at the traffic processor inside of NGINX or further out closer to CDN and whatnot. But sometimes that piece of code might be better applying to the backend application further in the back. So when you're looking at what you're doing, look at the size of the task, look at the performance of that, and place your logic, place the piece of code in the correct area of the stack. And on that, I will stop presenting, and we can go to some questions and see what do we have here from the question side. All right, Leonardo, did we have any questions coming from other systems? I mean,
yes,
we were streaming to this one, but I only see the Zoom chat.
Yes, exactly. Of course, I do have a question. Just a moment. So actually, the question is for you, Nick, and partly for me. Will you be presenting during the Tech Internals conference? Because like people in here, they enjoyed your talk and they would really love to learn more about NGINX systems.
You know what? It is possible, but I will ask the people here who are at this meetup. There will be a form, like a feedback form of some sort. So if you put that if you go into that feedback form And if you say that, yes, you enjoyed it, or maybe you didn't enjoy it, it's up to you to say whatever you want in the form. We'll see if that makes sense to expand a little bit deeper. Also, my contact information will be shared as well. If any of you will have any more questions of that, basically it's based on the feedback of people who are looking at this presentation. If you like the topics, let us know. We can do more.
Great, great. Thank you, Nick. And also from my side, I would like to add that as you can see, Nick's talk is like super in-depth tech, and it's super for hard skills, right? So this is actually the way we put our conference. So all the talks will be like this. That's why, like really hardware talks, they attract senior audience. So if you would like to meet senior specialists to discuss how would you decide this or that, please join us.
All
Yes,
right.
I think
Yes, I can see. Yeah, but I can see a question here on the Zoom chat. How would you debug JSX, probably NJS? So how would you debug NJS? There is a command line tool, which is literally called NJS, and it comes packaged. If you take NGINX packages for NJS, the command line tool it's also provided. So when you have that little piece of code there, you don't have to run a specialty full-scale NGINX system for that, although you can. You can take those little scripts or little lines of code and run them straight into inside of that command line interpreter. That's one way. The other one, which is probably what I would do there, I would probably containerize a small NGINX system with that code and basically run a test, run a debug system within its own container in an isolated environment. And the third way, which can be more complicated there, is to run it with NGINX debug log. However, the NGINX debug log, that one requires a specialty NGINX binary, which is usually provided next to normal NGINX binary. But the debug log can be overwhelming. It shows so much information. It is more designed to debug NGINX itself, maybe not necessarily the JavaScript code. So yeah, within those options, run its own specialty isolated container, run it in command line interpreter if that is possible for you, and look inside of NGINX debug log. Those would be the debug options. Do we have other questions here? Okay,
yes, I can see them coming.
Okay. How can we ensure that making web server configuration more dynamic doesn't slow them down? Are there simple tips, both flexibility and efficiency? Okay, that's a nice one. So performance is a good question. Of course, every time when you are creating a more complicated configuration, there is a chance for the configuration to slow down the server. Absolutely, it is possible to slow it down. However, there are several steps, several areas where we looked into that. First, if it is possible for you, if your configuration doesn't require a lot of changes over the lifetime of the project, if it is a more rigid configuration for the server, let's say it's a simple proxy, simple looking into a host header, simple looking into a couple of normal headers, some security features, and everything is laid down really nicely, look into what NGINX provides as normal configuration features. Don't dive straight into JavaScript if this is not needed. So don't use it if you don't need to use it. Next, if you are looking into implementing JavaScript configuration, we did ensure that starting of the JavaScript VM is done very efficiently. So those you might not necessarily lose a lot of performance when you are using the JavaScript implementation. And the third one, if it is very performance intensive, you might look further into WebAssembly implementations if your code or your scripts are more computationally extensive. So maybe looking further into WebAssembly could be another case. And if you are a really hardcore nerd who can do everything in the world, you might actually compile some things straight inside of NGINX and make your own modification of the NGINX core if NGINX is not providing you that ability straight up. So depending on the level of your ability and depending on the project specifics, you can basically find that level of that kind of a fine line between that flexibility and efficiency that you mentioned in the question. But as I said in the very beginning, if you need to do more things to traffic, if you need to do more modification, there is no miracle there. If you need to do something with a computer system, the cycles of the computer, the memory usage, it will be used. So to some degree, performance will be affected. All right. Do we have other questions coming?
Yes, I think there is one more question.
Okay. All right. Implementation of high availability of NGINX. Yes, that is possible. So for NGINX, there is a feature there, and I think we actually built the scripts and we put that in NGINX Plus. There is a set of scripts which are doing the VRRP-based high availability. When you take two NGINX instances basically in the same network, there is a feature in NGINX where you can bind to an address which is not owned by that machine at the moment of binding. So when you're starting NGINX, it bounds to the address that is not there. And based on VRRP, you can have that traffic landing on that machine later in case of a high availability failover. So it is possible. Look for VRRP for NGINX, but the full-scale VRRP and the full-scale HA configuration, that might be something that we do as a service for the customers. So there will be some information available on the website, but if you run into some troubles there, you might look into some of the official services in terms of high availability. And another point to mention, if this is high availability in the cloud, if it is some kind of let's say an AWS or an Azure cloud or whatnot, in those cases, the high availability feature is oftentimes designed and kind of provided by that underlying cloud system. So what I mentioned about VRRP-based systems, that's for your own data center when you have the networking layer of your own. If the networking layer is owned by somebody else, usually the high availability feature is specialized for that networking layer. All right, and I see, Leonela, you put the form out there, right?
Yes, that's correct. So everyone who joined us today, again, thanks a lot for it. And also, as Nick has already mentioned, we would like to receive your feedback to understand, like, did you enjoy the talk? What else would you like to listen to know about? So yes, please follow the link. Please give us some feedback, and we will be super happy with that. So yeah. I think we don't have any more questions. Thanks a lot, Nick, again, for joining us today as a speaker. It was super insightful as usually. We enjoyed it a lot. On the screen, you can see now the QR code, which you can follow and go to our YouTube, where you can find some more talks from our previous events from Cyprus, Serbia, Armenia, and so on. So please join us. And what else? Guys, if you are in Berlin, please join our offline meetup on 10th of December. We will have it on Kubernetes, super insightful, super chill, and also we will have glühwein as well. So please join us.
Oh yeah, that event in Berlin, I will definitely be there. I don't know if I will be talking, having any of those talks, but I will be at the event.
Great, great. Everyone join us. Okay, so thanks a lot. I think that's all for today, and see you next time. Bye-bye.